Hi, good afternoon. This is a class that we were going to do in person, but since we didn't have enough members, I decided to cancel it. But feeling guilty, I thought I'll record it and share it with those who had signed up, and then eventually maybe upload on YouTube for free. For anyone, even not an only member, can watch this. Why this topic? Because of all this, you have to be totally living in the closet, not to hear the hoopla and the demand for Ozempic, which has been in the news for last several months, especially endorsed by celebrities and being handed out like a candy. So, and that decided to prompted me to do a talk on this particular topic that I thought was timely. Now, diabetes is not a new disease, and when you get old, you become interested in the history of science. And so I will start with the history of diabetes, which is not a new disease. And as we shall see in a few minutes, a very old disease, but it has exploded since the Industrial Revolution, and especially much more so in 20th century and now even present time. So there is some good news on the front. And this is may or may not come as a surprise to you that this is the biggest cause of blindness in contrast to IEDs in war. It's the biggest cause for bilateral amputations, biggest cause of kidney failure and dialysis. And this is, we went through the COVID crisis and the HIV crisis, but diabetes has been always simmering since we did conquer the other uh, big endemic disease, which was tuberculosis. But diabetes has exploded, especially since the end of the Second World War and with the onset of affluent society. And not only that, it is affecting more and more younger people, and the treatment is getting costlier and costlier. And even there is some rise in type 1 diabetes as well. And so there are some interesting causes for that, but as we shall get over the next few sessions. Okay, so enough about the intro. And as you can see from this slide, that it's a staggering cost of diabetes today. It's about, so nearly 30-some million people in this country alone. And this is not the tip of the only problem in developing countries or so-called middle-income countries. That is even worse. And as time goes by and as lifestyle lifespan increases, this is going to get much worse in the uh, politically incorrect word of third world or developing countries or middle income countries such as India and China. Okay, and as much as 1 in 3 Medicare dollars is being spent for one way or the other taking care of diabetes related problems. And so this is not a small problem by any means. It's very timely. And how we are doing with this, these are some of the slides that I borrowed from a very erudite scholarly lecture from UCSF by a genuine diabetologist. And that's an interesting source for learning, and that's totally free. And and the abbreviation in medicine, we like abbreviations. So 39% of CKD means chronic kidney disease, and that people have visual impairment, and it's the cause of death in one way or the other. So enough to magnify the problems. What's happening presently? This is interesting that there is some, silver lining that the incidence of diabetes, at least as you can see from the left-hand side graph, is slightly decreasing from 2008. But when we look at the interesting things that it may be decreasing in self-identified white population, but in other ethnic minorities, such as Latino Americans, African Americans, that's increasing. And as we are living longer and longer, even though the incidence has decreased slightly, the total number of cases have gone up. And we are doing somewhat better in diagnosing the undiagnosed diseases now. And again, so the total incidence is increasing because 1 in 3 people over 60 will have diabetes in one way or the other. And now, most of these is so-called type 2, or as we shall see, it's called insulin resistance type diabetes, type 1. And there are some other rare types. As after pregnancy, sometimes one can get diabetes, or people, some rare people who have gallstones affecting the pancreatic duct. And I'm going to assume that most people know that diabetes has something to do with insulin and pancreas. So, but we'll again go over that in more details. And again, is the racial distribution is interesting, that you can see that amongst the Caucasian population or white population, its incidence is relatively, less than 10%. But when we get down to the Hispanic, African Americans, Asian, and again, the tribe or race as that I belong to, so-called Asian Indians. Okay, so and so that the incidence is worse. So it's especially cursed group, as we can see, and there are some interesting research that is being done by, and not only just in the United States, actually much more done in the United Kingdom, which has had a lot more Asian diaspora for much longer, since the early 50s. Okay. And so the second and third generation, so that those numbers are even much more impressive. Why are we concerned? Now, this is a rather busy slide, but it tells you that it's starting from the type 2 diabetes is the root cause of a lot of diseases such as cancer and other things, and is intricately related to obesity and being overweight. You can see, so these are, and all these illnesses are, part and parcel. These are just ones that we suffer as we get over, at least if not over 50, but over 60, and including heart disease, stroke, all the usual customers that we, and it's likely that most Americans, or at least, maybe more than half, are taking some type of medicine once they get over 60 for any of these numerous illnesses. Again, it's like nobody dies of syphilis and tuberculosis, but these chronic illnesses, which are, with all due respects to muscular dystrophy and ALS societies, and again, obviously, here we did not include Alzheimer's, which is a altogether a different can of worms all by itself. So, but you can see that it has a wide-ranging impact on our illnesses. Now, when it comes to medicine, this has always been a dilemma that as doctors, we make decision-making and make plans on the fly based on the current available information. We, as physicians, we like to think of ourselves as science, but many times the things that we have done or recommended have turned out to be hopelessly wrong, starting from bloodletting, which killed the George Washington, the founding fathers, to applying leeches, to all sorts of reading the bumps on your skull. So these have all been tried, including ECT therapy. So we have tried all sorts of things, and only to have egg on our face. So it's an art of science of uncertainty and probability. So it's just, and obviously we're trying to apply reductionism in the last probably 75 to 100 years at the most. And we have been remarkably successful. But again, as they say, the fat lady hasn't sung yet. And so we don't have all the answers. And you will see it that in diabetes, we got some of the advices, some hopelessly wrong from time to time. And we still don't understand some of the molecular basis of it. Okay, so it's so that's a big challenge that we have to make at bedside. And as physicians, we are all taught to do something, because as my obstetrician professor used to say, that you have to learn the masterly art of not doing anything, as to, putting on the other hand. So instead of just prescribing anything, as to like, and so even for diabetes, at least until in the 19th century, the medicine of choice was opium for this, and along with all the other sort of old wives' medicine that were tried, So, okay, and now getting back to the history, I just have a few slides that I just thought they're not relevant, but they were interesting, and since we do have time, and this was like a lot of the antiquities research that was taken by the Western uh, archaeologists, paleontologists, and stuff. So, Ebers Papyrus from ancient Egypt was discovered by a German named George Ebers, who lived in the 19th century, and in the Ebers Papyrus has 1,600 items on medicine, and but at least has some passing reference to what can be interpreted in broad terms as diabetes mellitus, as asha, which is actually, by the way, a Sanskrit or Hindu term, but how it overlapped in Egypt, that's anybody's guess. That refers to as polyuria, means putting out more urine. And the treatment is, obviously, the product of its time as to varieties of herbs and medicines have been recommended for that. But so it doesn't go any further. But the more credit to the Ebers Papyrus is that it defined, before Galen and Harvey in the 17th century defined circulation of the heart, but somehow along the line that knowledge did not get translated into Greek. And Galen, who thought that the seat of circulation was the liver, so that myth continued until William Harvey, after in the from the Royal Society, made the discovery of heart as of circulation. So it took another 1,500 or so years before the West caught up with the Egyptian logic. But the early, more systematic approach to diabetes was in the Indian classics, Ayurveda. And that was a lot more detailed. And let me go back to the slide there. I think I flipped back. Yes, that the Charak and Sushruta, which were a few centuries apart. Charak was around 300 before the current era. Susrus was 6th century before the current era. So they describe polyuria, means increased amount of urine, and also the taste of the urine, which was sweet. Madhu, madhu means sweet in Sanskrit, and described that. And he also described various symptoms related to it, that the tingling and unexplained fatigue, weight loss, bad odor to the breath, pale urine, and so he described, and he also some Ayurvedic type medicine that we described, and he also described two types of polyuria, which one which was sweet, another which was not sweet. So there are two types of diabetes, but here we're going to talk mostly about diabetes mellitus, the classic one, not diabetes insipidus, which has something to do with pituitary. And so this was, so they were, the Indian physicians were way ahead of their time. And so this is, and there are some good references that I have elicited in this thing. Even the ancient Chinese, where they had their finger on just about everything. And they also described fairly regular symptoms of wasting, thirst, sugar urine. And the classic book, Yellow Emperor's Classics of Medicine, describes various medicine. He was ancient China. He was Chang Chung Ching, very Chinese name. He was referred to as a Chinese Hippocrates, and he described various symptoms, and he recorded sweet urine, and mentioned the characteristic symptoms of all these diseases. And again, he proposed the abstinence from wine, salt, and even sex. Why that? That's beyond. Perhaps, they were losing their sexual ability anyway. Diabetes causes impotence, so that was appropriate. And not to be outdone, in the heydays of Arabic medicine, Avicenna, or the physician at par excellence, he described varieties of diarrhea of kidney and abnormal appetite. He also described what obviously we know now as complications of diabetes due to infections, gangrene, a carbuncle, which is a non-healing local infection which occurs on the back, and including tuberculosis. So he described all of these in quite details. And there was a nice movie made about him, starring Ben Kingsley, about Avicenna. It was called The Physician, which may be of interest. It was like a made-up story about him. So it was, and he was very prolific, as you can see, the canon of medicine. He wrote several volumes of it, describing, and he also was the first one to describe optics in a much more scientific manner than Plato and Aristotle did. Okay, not to be outdone, this is, now I copied it from Dr. Google, a beta. So that's how the word, was coined and translated into the melting down of flesh and limbs into urine. So, and this was, the Greek physician Aristeas, who gave the first complete medical description. And so this is how, and it took several hundred years, as you can see, for the word to appear in English language as diabetes. So that was the origin of the word. So it came from diabenin, meaning to pass through. So it's composed of dia means through and meaning to go. Okay, so that's the origin of the etymology of the word. Okay, interestingly, the father of Western medicine, Hippocrates, did not say much about it. And it was, and Galen also described this as diarrhea of kidneys and associated. So they were on the right track, to give them credit. Now, then nothing much happened for several hundred years, as you can see that the name was on. And finally, after in the early Enlightenment era, Thomas Willis, the physician par excellence, who was well known to neurologists as circle of Willis in the brain. Okay, the blood vessels are there, right? So he describes his diabetes or pissing evil. So he described a great deal more than they drink. So it was wonderfully sweet with honey. So, and he was, okay, just a second. I think I need to pause the recording for a second. And okay, so we were talking about Thomas Willis, and so he put things on the scientific basis. And then, and there were some, but even in his days, the diabetes was relatively rare, and it was so many physicians had never seen a case actually, and that occurred only in the upper classes, as the Brits would say. Those good fellowship and guzzling wine had a lot to do with it. And some other physicians, but now by the time the Edinburgh was a center for enlightenment, much more so than London, and then he described a variety of relationship with sugar disease. So there was a guy named Matthew Dobson, he described it. And then again, it was associated with digestive processes. So again, so there were, but now again, when it comes to treatment, it was pretty disappointing. And as you could see that there were other associations that was observed, because by this time they were observing blood, and you could see how the serum of diabetics showed lipemia, means the white substance that that is due to increased fat, the so-called triglycerides in the blood that were apparent. So this was some more scientific basis was being assigned to the underlying disease process of diabetes. Okay, so it was not just sugar, but also the association of fat was coming into knowledge. Now, there are some other intrepid physicians who had associated, and a guy who gets the credit for doing some type of scientific treatment was a chap named John Rollo. Okay, and as early as 1797, he associated food and diabetes together, and he prescribed animal diet, and he took several, again, his patients were upper class or military people, put them on a strict animal diet with meat and fat, associated the sugars with what we come to know now as carbohydrates, avoiding them bread and other carbohydrate types, including, and potatoes, obviously, being Britain, and showed that, and these people, they tried to make the sugar in the urine disappear. And that was their target that they were aiming for. And again, they learned from observations, because this was the days of traveling around the world, and they observed people, the Eskimos and the gauchos of South America, who lived without any vegetables and starches, so they were on the right track, and they did not have much diabetes, so the so-called carnivore diet. And again, we are going to the full circle with the enthusiasm for paleo diet, and we'll talk ad nauseum for diet as we go along in the class. And there were, at the same time, the French were also on the right track by recommending, in obviously a very French name, Apollinaire Bouchard. He recommended, green boiled vegetables, and by the time the increased association of exercise was also coming to the vogue. So people were on the right track in the beginning. Okay. Now, obviously, with this type of diet, people were fond of, human beings were fond of carbohydrates, sugar, and potatoes. And even a newborn baby loves breast milk because there is sugar in it. So the compliance was a problem. And Brits have good access to medical history. So a diabetologist named Robert Tattersall, wrote a book several years ago, and he has revised it recently, called The Pissing Evil. And that's a very extensive, almost exhausting history of diabetes. And I've read that on my Kindle, and a lot of this material is from Dr. Tattersall's history. And he was not just a medical historian, but he also has a credit for describing a new, relatively small portion of disease called a maturity onset diabetes of the young. And again, in medicine, we like abbreviation. It's called MODY, MODY, not Modi, nothing to do with Indian Prime Minister, by the way. And by this time, the chemistry was coming into the vogue, especially inorganic chemistry, and the varieties of tests were devised for urine testing. The initial urine testing was rather complicated and required almost a degree in biochemistry, and that was difficult. But then finally, people came up with a relatively quicker to understand color changing things as to how, and I'm not going to go into the chemistry of this, but how adding this Fehling's agent, the color simply changes. So even any physician at bedside can do this test. So this was, and the earlier test required, 50 cc of urine. It took almost 24 to 48 hours. So it is complicated, and with advances in chemistry, it became, and the pharmaceutical industries was right on the tail, and this is an example of the kit for urine testing. As you can see, that this is not and then later on in the early 50s, test tapes were introduced, and making it a lot more easier by varieties of primarily American companies. Okay, so this was a way of coming to putting some scientific basis on making some diagnosis, And again, by this time, the controversy among the medical community continued, because whether it was a disease of the blood, disease of the kidney, disease of the digestion. So, and because the pancreas is hard to reach, and it degenerates very quickly. So even on autopsy, people were not sure. And the varieties of authorities had pointed fingers at liver, some had pointed fingers at the brain, and disease of the, with Pavlovian enthusiasm, it was considered as a disease of the brain. So it was, okay, and so varieties of thought, schools of thought were in vogue at that time, until people were able to. Now, again, now the French had made distinction between two types of diseases, the diabetes maigre or the diabetic gras, lean and obese diabetes. So this was proposed by a chap named George Harley, who translated, from and French. So they were always, obviously, in medicine, there was a somewhat of a controversy about getting credit for who was first. Okay, so this was proposed as to skinny diabetics. So that's one can say that is a type 1 diabetes. It was associated with early death because of wasting, and the obese diabetes, which we now associate as type 2. And there are different disease processes, The type 1, as we shall talk about later, is an autoimmune disease where your body loses its identity and attacks itself and causes antibodies against the uh, pancreatic cells, which produce insulin, while type 2 is related to obesity and insulin resistance. So these two diabetes classification was put in a more scientific basis as early as 1858. And again, for those of you who are English majors, just to go over this thing, that the basic anatomy was, now this was the early days of endocrine or hormone system that came into existence with research on testicular hormones and estrogens, and again, the great giant, the neurosurgeon giant at Johns Hopkins, William Cushing, diagnosed Addison's disease and the disease that JFK had. So those were, and so endocrinology was, and on the same time, physicians at Mayo Clinic were diagnosing, thyroid disease. Okay, so varieties of endocrinology was coming to existence, and the word hormone, which has to do with the word was created, the secretory glands, where there were no direct nerves associated with the organs involved, such as adrenal gland or thyroid gland, but whatever substance was coming from the gland was affecting the whole body via bloodstream. So that came into existence, and various Russian scientists were involved in as well. So I have a whole slew of basic endocrine slides, and I think I had shared some book with some of you, which has to do with a book which gives history of endocrinology called Aroused, obviously nothing to do with arousal in the conventional sense, but it gives history of hormones and endocrine. So it's an interesting medical history. And so this is the so-called exocrine, means which that it is affected by, into the it's controlled by nerves in the endocrine gland. So this is now their pancreas has dual function. The exocrine function means secretes the various enzymes which helps in your digestion, okay, which is the large portion. So there are large, the majority of function is exocrine, which is it secretes the hormones, amylase, which degrades your starch, lipase, which degrades your fat, and trypsinogen, which breaks down the apart the proteins. But at the same time, very small but very critical portion of cells are those so-called beta, alpha, and delta cells, which secrete the varieties of hormone in very small quantity, but precisely controlling the blood sugar, insulin. And so it took a modern science a long time to get handle on it, because as you can see, that the endocrine cell are only 1 to 2% of the pancreatic tissue, but boy, are they important. Okay, so this was and a lot of this dissection was done in Italy at the University of Padua by various Italian anatomists. Okay, but again, it was it had to wait for several more years before we came to. Okay, now endocrine was of interest to the Nobel Committee because it has, believe it or not, it has been given the nod of the ultimate honor in medicine and science, with 7 Nobel Prizes, starting from the first one, which was proven wrong even before the ceremony was over. It was given to, all of you know, is Ivan Pavlov, so-called Pavlovian reflex. Okay, and that was proven wrong by the British scientists. Okay, but he got the prize anyway. So, and then varieties of other for adrenal research and thyroid research. So they've been a very favorite, so the Nobel Committee, which I did a lecture on Nobel Prizes, and that goes to various fashions. So vitamins were popular, and so were then became antibiotics became popular, then neuroscience, and now it's immunology and molecular medicine. You see, so that they go through various popularity phase, okay, as to what gets not and what is important. And the most recent one being obviously the mRNA vaccines, Okay, so finally, so these are some basic anatomy 101. As you can see, the pancreas is a tail-shaped organ which is wedged inside the first part of the intestine, which is the duodenum, okay, and the gallbladder, and that combines, and the secretions are secreted in the joint into the first part of duodenum to help. And this is why the pancreas is more closed on the backside towards the sun, so it's difficult to diagnose a pancreatic cancer. That's why it's much more difficult to diagnose. Okay, and so the varieties of effects that take place, the hormones have, are, and the varieties of medicine that were tried before, some plant extract called furazine was tried, and it was supposed to have varieties of other effects that were tried. But again, that had some more toxic effect, so it never caught on to the mainstream. Okay. Okay, yeah. Now, the first person to associate pancreas was a Russian scientist named Dr. Minkowski, and so it's a very fascinating story how the accidental discovery paved the way for diabetic research, and so obviously the Canadians have a lot more interest in diabetes, with the discovery of insulin. So Oscar Minkowski was a Russian Jewish scientist, and he was doing dissections of pancreas, and pancreas dissection was surgically very challenging. So along with, he had made a bet with another fellow surgeon named von Mering, and us can be removed pancreas without killing not the patient obviously, but the dog in that case, because animal research was the way to go before it was seen. So he was able to successfully remove pancreas, and the dog managed to live. But when he came next morning, the dog was peeing all over the lab, and he almost chastised his assistant. Said, "Did you take him out?" Said, "No, we have taken him out 5 times, but he was still peeing up a storm." So that's when they put two and two together, and at the same time. So this was, the association finally of the two, the association of pancreas secreting a chemical which has a lot to do with controlling amount of urine. And then he was able to test or taste, or probably taste the urine, and it was sweet. And so that is an interesting story about that, So by this time, the pancreas was denervated, means all the nerves were removed, type thing. So this was finally the first, scientific association of pancreas and chemicals that were secreted from that, okay, that were proposed. So, okay, and he also had a famous brother who was a mathematician, by the way, okay, and he was nominated for Nobel Prize, but somewhere along the line, did not get the recognition that he deserved, okay. All right, so moving right along, so that's an interesting piece. And it was left to a German medical student who died relatively young of, I think, tuberculosis or something like that, So, named Paul Langerhans, who studied medicine under famous physiologist Emile Dubois, and along with the father of pathology named Rudolf Virchow. Okay, so he was the first one who isolated the cells, the microscopic anatomy were different types of cells which were described, and these are his original drawings. He describes this that they were he thought they were responsible, the different shape, their small polygonal shape type of thing, and this, and that had a very small nucleus. So I described the pathological. So they were anatomists and pathology microscopists par excellence, and they had the advantage because Germany was far ahead of other countries in terms of microscope and lens grinding. Okay, so so this was the first finally. So, and this is the scientific picture of these are the islets of Langerhans and the cells that you can see in the middle. And there are varieties of other cells which secrete the varieties of hormone, the so-called. Now, obviously, in medicine, we always like to label things with the Greek alphabet. And so the beta cells were described as secreting insulin, amylin, which digests the starches, and there are varieties of other cells as well. So it's not, so the anatomy and the exquisite secretion of hormones is quite complicated. Okay. And so this was, and then again, there are a lot more about types of cells have been described in the more past. Okay, so now again, we have gone up to even epsilon cells, which were described, has to do with the satiety hormone called ghrelin. And so this is, again, finally, we're getting some scientific basis to it that the diabetes was a chemical disease, finally. And after eating, the glucose goes up. And if you don't eat, then the liver produces, stores a substance called glycogen. And varieties of early physiologists had pointed their finger at the liver, and correctly so, that the liver had a lot to do with forming glycogen. And during starvation, glucose is formed again. Okay, so there are about 2,000 calories worth of glycogen that is available. That thing. And then varieties of hormones that are secreted, including a glucagon. So when you're running, and even if you don't eat, it maintains the body, maintains the big concept that I want to get across is something called homeostasis. And that has a lot to do with, maintaining the balance as to so-called how to maintain status quo. And so these were the varieties of this thing, that varieties of physiologists had proposed this concept, and which were putting. So after meal, for insulin, and after 8 hours of starvation, gluconeogenesis, glycerol, is broken down. And then if you don't eat even further, then your fatty acids get broken down into ketones, which form the form of energy. So there are varieties of complex diabetic food interplay takes place. Okay, so all the substances like the glucose and the fat, they are interrelated. But somewhere along the line, because of what was, it's just like looking for things that are lost under the light. Okay, so our attention was focused on the sugar because that was the easiest one to detect in the urine. So the association of fats and other stuff was conveniently put on the side. Okay. Now, now at the same time, the granddad of physiology, Claude Bernard, the French scientist, he was proposed the milieu interieur, means the internal environment, and he's the first one who proposed the role of liver, which makes glycogen. So some of the earlier chemistry was worked out by, Claude Bernard. Okay, and his famous pupil was a guy named Sequard, Charles Brown Sequard. Okay, he had done some interesting research on testicular hormones. And there was a little bit of a craze that took place at that time. Okay, so Brown Sequard was a colorful scientist, physician. So he had injected himself with extract of dog testicles and promoted that he had vigor at age 72. And that incited the craze for the fountain of youth getting injections of so-called extracts of the testicular secretions of dogs and other animals. So obviously it didn't pan out. Okay, a lot type thing. So again, scientists can get off the wrong this pace. Okay, and that again incited the craze for Brown Sequard, for endocrinology, so he can just see how the craze for organotherapy, so injecting varieties of extract, Edison extract of adrenal, which was tried for treating anemia and weakness. At the same time, thyroid extract were injected, Brown Sequard, so you can just see how, and so that became therapy, and the business community was not far behind. They're promoting medicine for the future, so you can see how varieties of, so then it became like a popular craze, just like phrenology became craze. So all sorts of, in science, we can catch on to the fad as we've caught on to a lot of other fads over the times. Okay, so there was not much of a benefit, but uh, doctors can be as good as salesmen as anybody from Madison Avenue. So that, so science went through a lot of phase in the early days of endocrinology. As you can see how there were it's all sorts of neurasthenia extract of animal organs were injected. Obviously, whether it helped or not, you can see that that's the ad from New York Biological and Vaccinal Institute. Okay, so I don't know exactly what era it is, but it's probably in the early 20th century. Okay, so now at the same time, there were people who were doing legitimate research. Now, this was the time of suffragettes and protest for animal welfare and the vivisectionist. And obviously, before molecular medicine and discovery of genetics, animal research was popular, right? Starting from Pavlov onwards. So, and the two physiologists par excellence in London were doing research in Starling and Baylis on animal research on cardiac output, and some of the anti-vivisectionists, the ladies who surreptitiously got into their lecture and and wrote a book as to how the animals were being tortured. And unfortunately, this was a lot more hype than it was, almost like the Greenpeace activators who are protesting against illicit commerce. Okay, and they wrote a book, and the statue of a dog was erected in one of the London parks. And some of the medical students who actually were supporting their professors and understood the importance of it, went and uh, did some vandalism on the dog, and then it became the fight between the uh, gown and the street, so to speak, and so that when there was a libel case was started by either, I don't remember whether it was Starling or Bayliss, okay, and Old Bailey, and somebody had to pay some damages. And again, finally, this statue of the dog was recreated, and after the trial was moved to a small corner of London. So it's an interesting history as to how people's emotions and their British love for pets, very appropriate with with the Haitian controversy in the present time. Okay. And so Starling and Bayliss were, obviously in cardiology, they were a lot more important because they determine the role of cardiac output and the pressure volume relationship, so-called Starling curve, but again, we're digressing, so we won't get into it. And again, at the same time, the American physiologists were right on their tail of the Europeans, and they discovered the concept of Walter Cannon, who was the American physiologist par excellence, described the fight and flight term, and again, how the body likes to maintain, certain homeostasis, that if you're obese, the body likes to maintain status quo. That's why it becomes harder and harder. So what happens is when you lose weight, and then finally the body frames a new sort of level like water, and that's why it becomes harder to, so metabolism slows down. So again, that may be one of the explanation as to why diets fail, because the body has its own mind, because during survival for starvation, the mechanism is to hold on to the fat, so to speak. So this is, so this has been the big problem, and which again, so it is not basic, as we'll talk in the next few slides, it's not all physics. Biology is a lot more complicated and messy. So, okay. And okay, so again, so initially, people had success with weight loss, but then it plateaued out, so the varieties of research has frustrated not only just patients, but physicians type of thing. So, okay. Okay, I think we're moving right along. And now, at the same time, the clinicians were, rest their soul, they were trying their best. And some of the German scientists had this thing that they were, they had finally figured out that the carbohydrate, the three food groups were already outlined by the chemists, the carbohydrates, proteins, and fat. So they restricted carbohydrates and decided every physician of what is Pate has some type of diet, and all sorts of crazy diets were tried. But a German scientist named Karl von Noorden was in the right track. He placed something called the oatmeal and butter diet. So most of the calories came from fats. And again, and the importance of uh, making the sugar disappear from the urine was a way of titrating. So by reducing the carbohydrates and giving most of the calories from fat, they were able to help their patients live longer. I think so. Okay, so this was now there again, so this was, and this diet was caught on to it that even the father of medicine, Dr. Osler, William Osler at Johns Hopkins, also adopted this diet. So this was one of the few treatments that actually work. And at the same time, there were some crazy people who tried, well, the sugar is missing. Simple. Give sugar. And obviously, those people did not do well and they died. And some natural herbal medicine had some role. And this is an interesting uh, South Asian plant, Syzygium jambunicum. Nothing when growing up, I remember there were fruits called jambu that were available. So that had some role. So that was used, along with other medicine. And obviously the old standby of opium and salicylate was used. Okay. And some other secret patent medicines were tried, believe it or not, including uranium nitrates in Bordeaux wine. Now, that took some guts. As to how they came up with that is anybody's guess. Okay, so but at least some diets, did work successfully, I think. Now, when it comes to medicine, I'm not going to show these slides, because I think just watch it on YouTube basically, because while recording it, and if I want to put it on YouTube, that may come into copyrights. But so there's a link, that the granddad of Dean of University Diabetes Medicine was a guy named Elliot Jocelyn, the famous Jocelyn Clinic in Boston, and he had written varieties of textbook for diabetology, and he must have treated close to 50,000 diabetic patients, maintained meticulous records, tried varieties of diet, and tight control of blood sugar. Okay, and initially, obviously, he was, again, in favor of so-called starvation diet for diabetes, and then with that, he was able to, because obviously the ultimate aim for any physicians is to help their patient live. So varieties of methods, whether they had enough scientific basis or not, were tried. Okay, and by this time, they were astute enough that they were associated. There was fear of heart disease, and because of autopsies, and so again, so they were leaning towards the complications that were associated with long-standing diabetes, especially in juvenile diabetes. Obviously, the type 2 diabetes was rare because most of the people didn't live that long. The average lifespan was still barely 30 to 40 years. Okay, so they were primarily dealing with juvenile diabetes who died of ketoacidosis and coma. Okay, so their main purpose was to help them patients live. So there are varieties of fasting diets and trying to titrate sugars per diet. Okay, so the fear of fat was there right from the beginning. So again, as I said, I'm not going to show this slide. Okay, and this was followed by another sort of Curmudgeon physician named Frederick Allen, who went even further than Dr. Jocelyn with starvation diet, and he had a clinic at Columbia for a while. And he was almost brutal or ruthless in terms of starvation diet. And these pictures remind you of children from concentration camp, the so-called starvation diet. So they're focusing on, and some of them actually died from a trauma that I had to actually look up in inanition. So they were died from serious malnutrition. So again, but he showed that yes, at least I'm keeping these people alive. So and as this is a few years before the groundbreaking discovery of insulin, that a trial of 44 patients. But this was so hard. This was like reminds you of deja vu of later on occurred with early days of chemotherapy that was started of Boston Children's for leukemia. Well, the treatment was so horrible that the nurses were obviously refused to work in those areas. But being a stubborn physician, he insisted. And again, so there was some falling apart with Columbia, and he started a clinic by himself. And again, physicians make bad investors. So after a couple of years, in his clinic in New Jersey went belly up, so to speak. And it did not uh, catch on to with the majority, because that sometimes the treatment ended up being worse than the disease. But at the same time, a couple of other physicians who were trained in Chicago and worked in Michigan had a different rule. So they settled for not starving the patient almost to death and making them look cachectic. And they tried the so-called German approach of high-fat, low-calorie diet. Okay, and they started out with, again, a pretty drastic 1,000-calorie restriction, and then gradually increasing it. And so that's so that was the difference was between two schools of thought, as it has happened quite often in medicine, between the European approach and the American approach type thing. So there were varieties of schools of thought that were being tried. And not to be outdone, the great Mayo Clinic had treated a Montana farmer who was obviously type 1 diabetic with 1,500 calories, absolutely no carbohydrate, but high-fat diet, and just eating green boiled vegetables. Okay, and the farmer was a model patient, as which who are rare to say, and he started from age 30 onwards and lived until the discovery of insulin. He was placed on insulin, and again, in spite of being on insulin, he followed his diet religiously and lived to be, at least in his late 60s to 1950s. And surprisingly, at autopsy, he did not have the so-called known complications, which were the bane of doctors, after the after the introduction of insulin. That great Dr. Jocelyn, who used to hand out medals for people who lived, like those who lived, so medals for 25-year survivors. And after the so they kind of noticed that after they started treating people with insulin, they were handing out far fewer models. So everything was not kosher, in the Christendom, as you would say. Okay, that on one hand we're helping people live, but perhaps they're dying of other diseases. So we were trading one illness, and the immediate death was being postponed, only to have the patient succumb to cardiac death or kidney failure. And that was so we were dealing more with complications, and we were always. And this brings us to, after this, the great story of the Canadian discovery. I know I'll tell that story, and then we'll stop today, and then we'll continue with the next recording session. The story was that Dr. Benting was an orthopedic surgeon, and he had read some article in the book about secretions in an OB/GYN book of all things, about secretions of pancreas being responsible. So he was interested in doing dissection and went to Dr. McLeod, who was a well-respected physiologist who was interested in sugar metabolism at University of Toronto, and asked for lab work. And Dr. Clark thought, well, there's not much to be gained, because people have been trying to find out extracts of pancreas but have not been successful. And said, yeah, it's not going to work. But he kept, Dr. Benting kept, just a second. Okay, so Dr. Benting had the idea that was initially discouraged by Dr. McLeod, but he kept badgering him, so he finally gave him a small lab, and then he was able to isolate the small extract, but he was not much of a chemist, so he needed help from some real chemists. So And he was assisted by two medical students. One was Charles Best, another guy was Noble, and they took turns at helping him. So it's an interesting story as to how a surgeon who was, I think, an orthopedic surgeon, Dr. Benting, and two medical students worked initially. And then finally, they needed to purify this extract. And first time they gave it to, injected to an animal, a dog primarily, who was diabetic. And the sugar dropped a little bit. So the experiment was kind of not very reliable. Okay, so they needed to purify the extract further. So they needed a real chemist. So there was a real PhD chemist named Dr. James Killip, and he was assigned by Dr. MacLeod to help this overly ambitious surgeon. And so, and he used some extract with alcohol and was able to purify the extract and create a larger volume. But obviously, they had difficulty from dog pancreas glands, so they were not able to get too much of a volume. So the poor medical student was sent to go for a cow fresh pancreas from cows, and cattle were larger, obviously. So Dr. Collip was able to purify a larger extract, and now this time the animal experiment were dramatically successful. The sugar dropped from 400 to down to 200. So so obviously their hopes were encouraged. So there was the days before medical committees, and so this was so they were finally ready to try and on humans. So there were four actors, so Dr. Bentic, who was a surgeon, and then Dr. Best, who was the assistant, the medical student, Dr. MacLeod, who was the real renowned head of the department, and the professors were the high and mighty, and Dr. Collip, who was the biochemist, so they were, actually, filed, and so they were the four people on Mars. Why only two people got the Nobel Prize, not the other two? That controversy remains. But to their credit, they were gentlemen to an extent. So Dr. Bentig shared the Nobel Prize with Dr. Best, and Dr. MacLeod shared the Nobel Prize with Dr. James Collip. So at least they got some financial reward from that. Now, before this, there were other people who were working, and in fact, there was a Romanian scientist who had worked on this, and actually as early as 1905, and had published paper in Eastern European German journals. But somewhere along the line, he got neglected, and Romania, or his name was Dr. Nicholas Paulescu, Paulescu, and why his work was totally ignored, that's beyond anybody's guess. But the gnomes in Sweden work in a mysterious ways, and perhaps a lobbying had to do. Maybe his name was never proposed, because he was not proposed by the English-speaking world, So somewhere along the line, he got shortchanged, But that's the way the system works sometimes, So there were about 4 or 5 people who worked with this, and then finally they had to crank up this process, to on a larger scale. That's where the big American pharmaceutical Eli Lilly came into picture, and the rest is history. And that was the quickest Nobel Prize, that the paper that was presented in the Physiological Society, and within 2 years they were recognized, and then finally, just like Sean Connery being identified with James Bond, Dr. Bentig finally became identified with insulin for as long as he lived, and never really did publish any major papers. On the other hand, Dr. James Collip went on to publish varieties of paper in research, and so that's the history of insulin, and that changed the perspective. And this is just, I'll show this last slide for today, that the Nobel Prize, and you can see how this kinetic concentration type of prize, a young surgeon named Bentig, an assistant, removed insulin. Leonard Thompson was a boy, 14-year-old, dying from diabetes. became the first person to receive injection of insulin. Within 24 hours, his blood sugar improved dramatically, and that was the miraculous cure that took place. And that was the end of the starvation diet. And with this, we'll stop this particular